Welcome to Prince Maths Clinic, the e-learning solution at your pace and time. We have a very lovely question on the board. We are to find the value for the unknown, which is y in this equation. But before we go into the solution, kindly subscribe to this channel if you have not done so, and please recommend us. Please recommend this channel so that we can grow and serve you better. Thank you. I will put down my question first. Now, the first step to take to remove this root is to square both sides. So, doing that, this will be 7 to the power of y minus 11 to the power of y. Then I'll square this side. Then I want to square this side as well. Now, whenever you have a radical that is being squared, the square will cancel the square root. Let me take it again. Whenever you have a radical or a square root that is being squared, the result becomes what is inside the square root. So in other words, the square here cancels the square root. So I have the result inside the square root itself. That becomes the result. For instance, if I have square root of 4 and I'm to square it, my result will be 4. Why? Because square root of 4 times square root of 4 is what this implies. And square root of 4 is 2. Square root of 4 is 2. 2 times 2 gives you what? 4. And 4 is what is inside the square root. So to save us of all this stress, just the square cancels the square root. Therefore, this is 7 to the power of y minus 11 to the power of y equals to 77 to the power of y minus 121 to the power of y. Interesting thing here is this. I can factor out 11 from both here and here. This becomes 7 to the power of y minus 11 to the power of y equals to 11. If I bring out, this can be written as 11 to the power of y times 7 to the power of y. This can be written as 11 to the power of y times 11 to the power of y. So in essence, if I factor out 11 to the power of y, which is common, what I will have in the bracket will now be 7 to the power of y minus 11 to the power of y. Therefore, looking at this critically, 7 to the power of y is here. Remember, this is squared, sorry. And 7 to the power of y minus 11 is here. Please, don't make the mistake to cancel out like this. If you cancel out, it means that you will not obtain the complete result like you would have if you follow the method I'm going to use now. And the method I'm going to use now is special because I'm going to use substitution method. Everywhere I see this 7 to the power of y minus 11 to the power of y, I'm going to put a letter to replace it. So let me say, let q be equals to 7 to the power of y minus 11 to the power of y. So that means in place of this, I'm going to put it as q, it is squared, equal to this 11 to the power of y times, remember everything here is now q. So if I move this here, this becomes q squared minus 11 to the power of y times q equal to 0. I'm going to factor out q from here because q and q, they are common here. So if I factor out this, I will have q. The q squared divided by q, I have q left. Then minus all of this 11 to the power of y times q divided by q. I will have 11 to the power of y. All equal to what? 0. So I'm going to apply the zero product law here that says that either this q will be equal to 0 or q minus 11 to the power of y equals to 0. Therefore, q is equals to 0 or q minus 11 to the power of y equal to 0. Then I have to recall. Remember, we said that what? That let q be equals to 7 to the power of y minus 11 to the power of y. So in place of q now, I want to put 0 back so that I can obtain y, because we are asked to find y and not q. We introduce q. Therefore, putting 0 in place of q now, I will have 7 to the power of y minus 11 to the power of y equal to 0. Then, what do we do in this instance? I want to move 11 to the power of y here. The sign will change. This becomes 11 to the power of y equals to 7 to the power of y. Then I want to divide both sides by 11 to the power of y. 11 to the power of y. So this gives me 1. And this becomes 7 over 11 to the power of y. Because both of them are raised to the power of y, so I can put them like this, equal to 1. And we know that in mathematics, anything to the power of 0 is equal to 1, whether it's a fraction or a number. So I can say, therefore, 7 over 11 to the power of y must definitely be equal to 7 over 11 to the power of 0. It is only in this circumstance, because I use this 7 to the power of 11 because the base here is 7 to the power of 11. It is only in this circumstance that this can be equal to 1, because 7 to the power of 11 gives us 1. Therefore, since the bases are the same, the powers are equal. So I can say, therefore, my y equals to 0. So it means that one of the values for y is 0. So I can state it here that y equals to 0. So that is for case 1, where q is equals to 0. So let us look at a case where q minus 11 to the power of y equals to 0. Let's look at a case like that. If this q minus 11 to the power of y is equals to 0, so it means that my q will be 11 to the power of y. Right? Then we can put 11 to the power of y to replace q here. Therefore, it means that 11 to the power of y will now be equals to everything I have here. 7 to the power of y minus 11 to the power of y. Right? So if I move 11 to the power of y here, it's going to be 11 to the power of y plus 11 to the power of y, all equals to 7 to the power of y. Now, 11 to the power of y plus 11 to the power of y is like saying x plus x, which is 2x. So, because they are the same, so I'm going to just put 2 multiplied by 11 to the power of what? Y. So, therefore, I want to divide by 11 to the power of y. I will divide both sides by 11 to the power of y. So, this will take out this. Therefore, I'm going to have 7 to the power of y over 11 to the power of y to be equal to 2 over 1, which is 2. So I can state it like this, that 7 over 11 all to the power of y is equals to 2. Therefore, to obtain my y, I'm going to take the log of both sides, or take the natural log of both sides, or take the log of both sides in base of 7 over 11. If I want to take the natural log of both sides, I will have it as ln 7 over 11 all to the power of y equals to ln 2. So this y comes here. This becomes y ln 7 over 11 equal to ln 2. For me to obtain y here, my y becomes what? Ln 2. Then I want to divide by this, divided by ln 7 over 11. Another nice way of writing this is to say y is equals to ln 2, then divided by ln 7 over 11. Now, looking at the law of logarithm that says if I have log a over b, this is as good as saying log a divided by log b. They are the same. And what does this imply? Division. It implies that log a minus log b, especially looking at it from this angle, right? So in essence, I'm going to treat this using this law. It will now become y equals to ln 2 over ln 7 minus ln 11. Punching these figures in the calculator, ln 2 will give us 0.6931, ln 7 will give us 1.9459, then ln 11 will give us 2.3979. So, and if you evaluate everything you have here, you are going to get negative 1.5334. So it means that the second value for y that suits into this equation is minus 1.5334. These are the values for y that satisfies this particular equation. Thank you for watching, and please don't forget to subscribe to this channel so that you can get more interesting and educative math lessons just like you have watched. Thank you. Bye for now.